Today we're finding the enthalpy for this reaction right here. And in this problem, it gives you the reaction and the Vesper model, and then it gives us these bond energies right here. And this is what we're going to use to find the kilojoules that we need. So since this is a bond energy question, you're not going to take the products minus the reactants, you're going to take the reactants minus the products. And this one is a pretty simple problem. Here we can see the H's bonded together, and we can see that right here too. But we can see that there's a coefficient of 2 right here. So to write this out, we're going to do the coefficient of 2 times the kilojoules over moles that it gives you, which is 436. And then we're going to add that to this little bonded area right here, which it gives you right here. And there is no coefficient, so you're just going to add that to 499. So after you get that, this part is probably the part that's most complicated. You're going to subtract, but you can see here that right here where it gives you the value for the O to H bond, it only gives you this right here and this right here. That is 2 separate bonds of this. So that's one OH bond, and then that's another hydroxide bond. So that's 2. But since they're both being multiplied, that's 2 hydroxide bonds times 2, which is actually 4. So instead of putting a coefficient of 2 here, since there are 2 hydroxide bonds, you're going to put a coefficient of 4 and then multiply that by 463. And then we can put that into our calculator. 2 times 436 plus 499 minus 4 times 463, which is going to give you, sorry, it's hard to see, negative 481. So yeah, that's how you do that problem. Thank you.